It's a place that's full of wound-up executives making bad decisions. And she thought, well, let's try it out at some unnamed company. I think this is really important. Watch this space. So, how would I connect these things, right? Well, you've seen wired headsets, and they can kind of get in the way. And I know that people make, for example, for cars, you can buy now tires that tell you their temperature and pressure and whatnot. And obviously, wiring wouldn't work because you would wrap it around the axle of whatever it was. It wouldn't scale, right? So there's reasons to go wireless besides convenience. And the question is, what do you got? So, you all got phones in your hands. Most of you do. How many have Wi-Fi in their pockets? I would say the majority of you do. How many of you have Bluetooth in your pockets? Pretty much the same. How many of them do you know of have Bluetooth Smart, low energy in them already? It turns out in the last calendar year, 2013, it was difficult to buy a smartphone that didn't have Bluetooth low energy in it. This year, it's even harder. So the aggregate market of smart-ready LE cell phones now is probably 1.5 billion, maybe close to 2 billion over the last three years. So you all have them in your pockets, whether you realize it or not, unless you've got a flip phone, something that's relatively obsolete. Okay, so who has Z-Wave in their pockets? If you have a Galaxy S5, you might, because they have a heart rate monitor that talks that way. Who has Zigbee in their pockets? Crickets. I thought so. I was yesterday at the IFA show, and I saw the Samsung Smart Home, and they have all these things talking to each other. And I said to one of these people, so what's the technology here? And I don't know. 3 other people said, I don't know. And they sent me to a marketing guy who said, I think it's Zigbee. Really? Because Samsung sells about 400 million Bluetooth low energy enabled smartphones per year. 400 million. The aggregate market for all for all Zigbee enabled things sold in the last 9 years is about 100 million. So, what do you got? That's my answer. Any other choices? Anybody got some radios that are not 4GE that I haven't mentioned here today? Crickets. Okay, I made my case. So my recommendation is, if you want to build a successful market, start by leveraging something that already exists. Many of you have probably heard of Metcalfe's law. Am I right? Metcalfe basically said that the utility of something is proportional to the square of the number of other devices it connects to. Until it saturates, I suppose. All right, so I would recommend for state radios, for low duty cycle, low power, maybe scavenged power, use low energy because it's there and it's cheap and it's easy. If you need low power streaming, Bluetooth Classic is actually better, and it's still lower power than Wi-Fi. The next generation of Bluetooth headsets will draw 5 milliamps at 1 volt when they're transmitting, and 1 milliamp when they're receiving. 1 milliamp. You can run something a long time on 1 milliamp. For high data rate stuff, use Wi-Fi Direct. In technology as well as in nature, if you build something that works, many times that technology gets exapted for something else. How many of you ever watched the Cosmos series in the United States? Right? They had a great sequence about how eyes evolved. You don't need intelligent design to get them. So people built Wi-Fi for wireless network connectivity. And now the Wi-Fi capability is being exapted, EXAPT, for peripheral connectivity in addition to network connectivity. Same thing is happening here. So we've got connectivity. Now what? It's only good locally. I can go buy my Fitbit and I can get an application that runs on it that talks to the Fitbit. That's very nice. But the data might want to go somewhere else. There's all these web services, they want data. How do we connect it to them? That's the center of this presentation. All right, 3 models. First one is, let's support the stuff that's sold now. Like, let's suppose, for example, I'm wearing this heart rate monitor. It was designed to talk to a cell phone. So we have a technique that's already standardized in the Bluetooth SIG for how a web client reaches through a gateway to talk to the heart rate monitor. Second, let's suppose I've got a device that wants to go out and reach to the web. So we're testing the HTTP proxy service next week in Amsterdam, and after that, at the end of October here in Berlin. And we'll probably finish testing it by then. Bluetooth SIG likes to exhaustively test specifications before we inflict them on the public. We'd like things to actually work, and that's what we're going to do. So an internet-aware device can tunnel directly through a gateway to say to this web server, here's what I want, here's how to find me. And the third model we're working on, which fits certain kinds of home network applications, is to embed an IPv6 stack or a 6-LoWPAN stack directly in the device. We're working on all 3 of these things. One is done, the other 2 are being tested soon. In my day job, I am the chairman of the Bluetooth Internet Working Group, which is where this happens. So, here's how they work. First case, I left my pointer somewhere. All right, imagine the far left is my heart rate monitor or my Fitbit. This allows a web client to go through a gateway to talk to it. Use it as is. There are probably 3 billion GATT server devices sold as peripherals every year right now. So it's a good place to start. Petra, you were talking about doing work using Bluetooth connected health and fitness sensors. They're probably existing sensors right now. The things I'm describing right now would work for what you're doing right now. Bird in hand. HTTP proxy service, suppose this little thing wants to go back out to the web. This is how it would work. So you put a client in the gateway and go out and talk to any web server that you want to. Third way is you put internet directly inside. For the wearables that we're talking about right now, that's probably not a big deal. If I'm trying to support some of the standards for home automation, for example, and you're worried about cross-connectivity between the Zigbee thing and the Wi-Fi thing and the name that other wireless technology thing, and they all speak IP natively, then putting 6-LoWPAN in the device is a good approach, and that's what this will support. Any questions about these 3 models before I continue? All right, save them for later. Right? So, big story. You take these LE things that talk to the phone already, and you download an application that performs these functions, and that goes out in turn and talks to the native LE devices as servers, as clients, or as IP inside. That's how it works. Now, I talked a little bit about what the 3 choices are. In general, as I say, the RESTful stuff works for the things that you already have in your lab. If you've got an internet-aware thing, that's a new design. We'll ship that specification soon. And for the 6-LoWPAN stuff, We're going to ship those specifications probably early next year. The Internet Engineering Task Force, these are the people who standardize things that are called RFC this and RFC that. RFC means request for comment. They're working on a standard for 6LoWPAN over Bluetooth Low Energy. The Bluetooth people will test our piece first, and we'll give it to them. They'll test it some more. And that means the complete spec will be ready early next year. So, do I trust this stuff? Security should not be an afterthought. Who out here wants to have their body hacked? I think that's more crickets. Nobody. I don't think you want to be monitored without your permission. Even my 92-year-old father, who might be able to have more independence staying at home if he's monitored, is afraid of the monitoring. You don't want anyone affecting what happens to you without your permission. In the Bluetooth world, one of the things we've standardized is blood glucose monitor. And we're about to finish standardizing a blood insulin injector. That's all very useful and valuable, but you don't want somebody else hacking in and giving you either no insulin or too much. Either will kill you. I don't know how many of you noticed, but several years ago, the former Vice President of the United States, Dick Cheney, had a pacemaker installed, and it was designed to be wirelessly controlled. He made sure the Secret Service got into it and made sure that it could not be wirelessly controlled so that some hacker couldn't kill him. Anyway, in the Bluetooth world, we have encryption as good as anybody right now. Regular Bluetooth has really good key generation as well now. Bluetooth Low Energy will catch up shortly. If you take Bluetooth native security today and you monitor the key generation process, you only have to break 20 bits of entropy to own the keys. You can work around that today with QRS codes. Who here doesn't know what a QRS code is? It's sort of like a two-dimensional version of a barcode. In any case, you can use those methods today as workarounds, and they're as solid as they could be. But for any random wireless connectivity without out-of-band access, the Bluetooth world will have caught up there by the beginning of next year. And what you want is the math on the security to be so hard that that's not the obvious attack surface. You want it that the only way to break into the system, which is what everybody deals with all the time, is phishing spam, where they trick you, they lie to you in some fashion to providing something that they can then use to break into your system. If the math is hard, their attack surface is your head. And I'm really worried about that with my elderly in-laws because, you know, they don't recognize when someone is abusing them on the phone. Unless you can train them to basically hang up all the time, they're really vulnerable. And that's true, I'm sure, in every country that has phones. Okay, so why would I want to bother with these things? Answer, talked about it today. Get healthy, stay healthy. All of us engineers, have sedentary jobs. We're at the risk of eating more than we burn off. We just had lunch. Costs are huge. Activity monitors can tell us what energy we're spending. Although they don't actually monitor what we eat and drink yet, this will tell me how far I've been walking, how many stairs I've climbed. It won't tell me if I've been drinking any sodas or water. It can't tell the difference yet. We may need, then, health monitors to tell us how well we're doing. As was presented today, we can keep track of whether people are falling down or not, and perhaps with the right kind of sensor technology, we can tell when they're in danger of falling down. Like, one can wear a Fitbit, and something with haptic sensors could say, she's fallen. But if you're watching people with a Kinect, as was presented today, maybe you can tell when they're in danger and call the nurse a few seconds before they fall and keep them from breaking that hip. Both of my grandfathers died that way. And in the Bluetooth world, we standardize heart rate, blood pressure, pulse oximeters, blood glucose, et cetera, et cetera. These are all off-the-shelf things. You can buy them on the store, on the show floor. But there's a couple of things I'm worried about. For example, suppose I've got a smart house. Warning. And it's talking to the bathroom scale, it's talking to the mirrors, the cameras in the house, et cetera, et cetera. So the man comes down and he says, "Give me another beer, Hal." And the refrigerator says, "I can't do that. You have disturbing flab abnormalities." Right. So many of us don't want our houses that are actually going to be nannying us. And the other danger, here's a case where the boss has a biosensor. He's going to give it to the Dilbert character, and he's like amazed. This man cares about my life. But what's happening is the company is monitoring him, and they're saying, well, he's not breathing too hard. Give him some more work. For the last 10, 15 years now, I have seen people putting Fitbit-like things on people's shoes, not to help them be healthy, but so that companies can monitor your physical activity. They can tell whether you're sitting and smoking or whether you're out running around helping somebody. People driving trucks for at least 10 years have had things on the roof of their trucks that can tell where the truck is, how fast it's moving, whether they're moving or sitting still, are they getting enough rest, all those things. The companies monitor them now. Get used to it. Companies have been monitoring your email for a long time. Get used to it, okay? And these people, the corporations are not exactly our friends. Now, killer application, aging in place, as I was referring to. Nobody here is getting younger that I'm aware of. Next month, I will be hex 40. I'll be 64, right? So many of us hope to retire and stay in our homes. My wife and I tell each other that more or less every day. We would like to keep our independence, and in fact, if we're successful but can keep it secure, remote monitoring should allow people to stay at home longer than they might otherwise, which has huge costs. My in-laws, for example, were living at home, and they were paying their property taxes. They'd paid off their house. Their living expenses were a couple thousand a month in the United States, which is saying something. But they needed assisted living. They moved to assisted living facility, cost them $6,000 a month for all the care that they need. So the time that you can postpone needing assisted living has huge financial consequences around the world. I don't think I need to get further into that, but I think you all know what I'm talking about. A couple years back, there was an issue of The Economist. It had some guy on the cover. He's riding his Harley-Davidson motorcycle, and it says, 70 or bust. Because what they want is guys like me to work until we're 70 so that we don't load national retirement pension systems any sooner than we have to. So, another killer application, keep some memories. As I was mentioning earlier about Google Glasses. So I've been predicting for a long time that someone's going to build something like that. They did, and it works. And the upside is, it would work. I could look at him and it would say, that's Kiko. Yes. How long has it been since we talked to each other, right? I could see him in January again and it would know right away that it was Kiko. That'd be cool. But, like I say, all the national security agencies have this stuff already. Google has it already. And whether they like it or not, in some countries it's illegal to use it because it's a violation of privacy. So, where do I think we're going? I haven't run out of time yet, have I?
We are in time.
Just?
We are in time. You can continue.
Well, I'm almost done. Right. So, my predictions is these smart stuffs are going to continue to proliferate. So, some of them will enable applications that we consider compelling. Those we're going to want to connect to the web if we can do it securely. so that applications that we trust can do important stuff for us. And it'll be attracted to it, and we will neglect security at our peril. One of the 2 articles that I want to write for the Consumer Electronics magazine for the next year, one of them is details about how some of these internet connectivity mechanisms work, and one of them is to write about how CSR mesh and Bluetooth mesh will work at extending these things in houses. But I think on top of that, I need to explain to people about the 150 different SDOs that think they're going to standardize the Internet of Things space, and how this stuff can grow up and shove into that. So, resources. Last 3 magazines. You get these, right? Because you subscribe. Find them if you haven't recycled them yet. Books on short-range wireless, low energy. There's some LinkedIn groups to get into. And this is where you can find me. Questions? Somebody. Tom, my favorite shill.
So, one of the big things I think that you mentioned several times is security and privacy, right? So, what are we going to do to ensure security and privacy?
It's really complicated. There are some standards development organizations that are ignoring it at their peril, and there are some that are paying close attention to it. One that I'm particularly attracted to, there's a consortium that involves Qualcomm and Microsoft and some other companies, and they're trying to standardize by exporting open source code. And to me, a crucial feature of the open source code is that security is end-to-end rather than link-and-link, right? So if I have an application on the cloud somewhere that talks to my Fitbit, security is at the application-to-application level, not on the link-to-link level. So it doesn't matter whether I have a secure connection from my gateway to my Fitbit. What matters is if I have negotiated secure connection all the way through to the application, wherever it happens to be. I like that approach. I think it's going to turn, there's going to be a Darwinian competition amongst those 150 different standards development organizations. Some of them are going to be stupid, some of them aren't. And I think that the ones that have useful characteristics like that they're secure enough that you can trust will eventually win out over the ones that aren't. Capiche? More questions? Come on. Yes, sir. We need to give him a microphone.
You talk about predictions. So I ask you a prediction to make.
Sure.
When will the Consumer Electronics Society meetings will have reliable internets worldwide?
That is a budget question. And today, I have just been elected to join the Board of Governors where budgets get made, but I don't even start until January. So I have no visibility into the budget for these conferences until January. I would, as a candidate for the Board of Governors, like to support practitioners to have internet access, with the caveat that when you're at a conference like this, I like it for the people in the room to not be lost in their email when people are talking to each other. I'd like them to actually be paying attention.
Another possibility, maybe they would like to understand better your talk if they have access to a browser. If something they don't understand, they could see what it is.
That's I agree, that's helpful. And another thing that would help long term, I would expect that at some point the AV people are recording this, broadcasting it live to CES members who can't make it to Berlin or to China or to Las Vegas, so that we're educating more people in real time than we could before. That would be a good reason to have internet access and give people tokens that allow them to log in and listen to this stuff. That's something we can take up in the CES Board of Governors budget for the next 3 years. And that's something that I would support. Thank you for the question. Any more? Hearing none, I'm going to pass the chair back to Kiko here.
So, thank you very much, Joe.